Welcome to this deep dive, learner. I want you to imagine a world where 4% of all public code commits globally are written by a single AI.
And we're not talking about a massive team of outsourced developers here.
Right, definitely not a giant tech conglomerate either. We are talking about one artificial intelligence, an AI that is so widely adopted, it even helped plot the course for NASA's Perseverance Mars rover.
Which is just an absolutely staggering fact to wrap your head around.
It really is. And today, we have a truly mind-bending mission ahead of us. We are exploring the transcript of a fascinating Y Combinator video featuring Boris Cherny. He's the creator of Claude Code at Anthropic.
We're going to be unpacking the really accidental origin story of this tool.
Yeah, how it is fundamentally changing the very definition of a software engineer.
Yeah.
And the terrifyingly fast exponential curve of AI capabilities. Okay, let's unpack this.
We really do need to look closely at this transcript because whether you are a coder who has been in the trenches for 20 years or, just someone trying to survive the incoming wave of automation in your own industry, this deep dive reveals the brand new blueprint for human productivity.
The rules of how we build things are just completely shifting, aren't they?
Completely. How we work, how we plan, they are being rewritten not on a decade-long scale, but literally on a month-to-month basis. What we are discussing today isn't just a coding tool for developers. It is a crystal-clear lens into how AI is going to interface with absolutely every digital task you do moving forward.
That is the perfect way to frame it. And honestly, the wildest part of this whole paradigm shift is that it started completely by accident.
Right, it wasn't some grand master plan.
Exactly. If you look at the origin of Claude Code, there was no multi-year master plan at Anthropic to build a revolutionary command line interface. There was no massive whiteboard session with executives.
The team was just in what they call explore mode.
Yes, explore mode. Boris just wanted to try Anthropic's new API. That was literally it. And because he was operating as a solo developer at that specific moment, he didn't want to waste weeks building a complex user interface.
So he just shoved it into a terminal.
He shoved the AI into a humble 1960s-style terminal window on his Mac.
It really is the ultimate example of constraints breeding innovation. He didn't want to deal with designing buttons or complex layouts or responsive web pages.
Too much friction.
Way too much friction. He just built a little chat application right there in the raw text terminal so he could ask the model questions and get answers. It was raw and immediate.
But then, this massive aha moment happened. It is what the transcript describes as feeling the spark of AGI, artificial general intelligence.
That spark is such a huge moment in the source material.
It is. Anthropic had just released tool use for their models, and Boris decided to give the model a simple bash tool.
And for those who don't know, a bash tool basically gives the AI the ability to run terminal commands on your computer, just like a human typing on the keyboard.
Exactly. So he didn't really know what it could do yet, so he asked it a completely random, almost silly question. He typed, "What music am I listening to?"
And the model just took over.
The AI autonomously wrote an Apple script, executed that script to check his Mac's music player, read the result, and gave him the answer. He realized right then and there, the model just wants to use tools. It actively wants to interact with the environment.
What's fascinating here is how the simplest, most constrained design actually enabled the most profound developer experience. Terminals are incredibly archaic by today's standards.
They really are.
When you are working in a terminal, you are dealing with an 80 by 100 character grid. You have maybe 256 colors to work with. You have no DOM, which is basically the underlying structural blueprint that makes web pages look like web pages.
Right, no native mouse clicks either.
Exactly. No native mouse clicks unless you build some highly complex virtualization just to fake them. As Boris noted in the interview, navigating this environment felt less like modern software development and more like discovering a retro BBS door game from the early internet days.
He specifically compared it to the text-based game Lord of the Red Dragon.
He did. Yet, inside this incredibly retro, highly restricted text-based environment, the AI was navigating complex modern systems and writing production-ready code. It actually made the grueling work of software engineering feel like play.
Here's where it gets really interesting. You would assume the logical next step after finding this massive, unexpected success is to start polishing it, right?
Yeah.
To build out a massive, beautiful graphical interface, lock in the feature set, and sell it as a finished product.
That is what any traditional software company would do.
But looking at Anthropic's philosophy, they do the exact opposite. They have a very specific mindset. They do not build for the models today. They build for the models 6 months from now.
That is a staggering mindset shift, especially in the tech industry where everyone is utterly obsessed with current quarterly releases. To really understand it, you have to understand a concept called the bitter lesson.
I love this part of the transcript.
It comes from a famous essay by AI researcher Rich Sutton, and Boris literally keeps a copy of this essay framed on his wall at work. The core premise of the bitter lesson is that you should never, ever bet against the model's raw capability improving.
So in traditional development, you try to fix the model's current flaws.
Right. In traditional software development, when an AI model isn't quite good enough at a specific task, engineers naturally want to build scaffolding around it.
Let's pause there so we don't lose anyone. What exactly does scaffolding look like in this context?
Great question. Scaffolding is all the extra hard-coded logic that a human engineer writes to hold the AI's hand and force it to perform better.
Give me an example of that.
Okay, imagine the AI gets confused when trying to read a massive file. An engineer might write a bunch of scaffolding code that automatically breaks that file into 10 smaller pieces, feeds them to the AI one by one, and then stitches the AI's answers back together.
Got it. And that human-written code might give you a 10 or 20% performance bump today?
Exactly.
Which sounds incredibly useful right now. But the bitter lesson says that scaffolding is actually a trap, doesn't it?
Precisely. It is a massive trap. Because in 6 months, a new, vastly more capable, more general model will be released by the AI labs. And that new model will just be able to read the massive file perfectly on its own without any help.
It renders the human effort completely pointless.
All that complicated scaffolding you spent 3 months designing, writing, and testing, it instantly becomes technical debt. It is wiped out entirely. So the Anthropic philosophy is radical. Don't over-engineer solutions for today's limitations. Just wait.
The underlying model will catch up and solve the problem natively. But wait, doesn't that philosophy lead to an incredibly unstable environment? Boris mentioned that Claude Code has been written, rewritten, and rewritten again.
The churn is unbelievable.
Get this. There is no part of Claude Code that was around 6 months ago. Absolutely none of it. About 80% of the entire code base is less than a couple of months old.
They are essentially deleting their own product constantly.
They're literally unshipping tools every few weeks because the AI simply outgrows the need for them. I have to ask, isn't tossing out code every 2 months a massive waste of resources? How do they justify that level of churn?
It looks like a waste of resources if you view code as a permanent asset the way we used to. But in this new paradigm, code is practically disposable.
Disposable code.
Yeah. You justify the churn because the speed of iteration is so fast that holding on to old code actually slows you down. It is like building a really intricate sandcastle while the tide of AI capability is rushing in.
That is a great analogy.
You have to be willing to let the water wash it away so you can build something better on the new shoreline.
Which naturally brings up the question of how they actually decide what to build next if everything is so temporary. The driving force behind Claude Code's feature set is a concept called latent demand.
Latent demand.
Latent demand is all about observing what users are already jumping through hoops to accomplish and simply removing the hoops. The transcript makes a great point. You cannot force people to adopt a totally new behavior from scratch.
No, humans are too stubborn for that.
But if you observe the market and make the thing they are already struggling to do easier, they will flock to it instantly.
It is the path of least resistance for product development. And the perfect example of this in the Y Combinator video is the story of how plan mode was born.
Yes. I love this anecdote. So Boris is looking at GitHub issues and internal feedback channels late on Sunday night, like 10 p.m., and he notices a massive amount of this latent demand.
What were the users doing?
They were practically begging the AI, essentially typing prompts like, hey, come up with an idea, plan this architecture out step by step, but please, whatever you do, don't write any code yet.
They were terrified of the code dump.
Exactly. People were trying to use the chat interface to spec out complex system architectures without the AI immediately vomiting 100 lines of code that they would then have to review.
The users were trying to force a workflow that the tool wasn't explicitly designed to handle yet. They wanted a thinking partner, not just a code generator.
So Boris sees this clear friction at 10 p.m. on a Sunday, realizes the latent demand, writes the underlying code for plan mode in about 30 minutes, and ships it by Monday morning.
30 minutes.
And plan mode is so elegantly simple, it literally just adds one sentence under the hood telling the AI, please don't code. It was an absolute instant hit with the users.
But if we stick with the philosophy of the bitter lesson in building for the future, we have to acknowledge that even plan mode has a limited lifespan.
Oh, really? How so?
Think about it. Right now, as a user, you start in plan mode to make sure the AI actually understands the architecture you want. You are essentially babysitting the planning phase so the AI doesn't run off in the wrong direction and waste time. But as the models get smarter, as we move toward whatever comes after the current generation of Opus models, the AI will just figure it out from a basic single-sentence prompt. You won't need to babysit the plan. The AI will bypass that human oversight phase entirely.
So if you don't even need to babysit the planning phase, what happens to human output? Let's talk about the exponential curve of productivity here, because the numbers in the transcript just shatter reality.
The numbers are insane.
Anthropic engineers are seeing a 150% boost in overall productivity since Claude Code launched. That alone is wild.
Yeah.
But then there is a reference to a post by developer Steve Yegge.
Oh yes, the Steve Yegge post.
He claims that an Anthropic engineer using these tools is currently averaging 1,000 times more productivity than a peak Google engineer. I have to pause there. 1,000 times. Is that an actual measurable metric or just Silicon Valley hyperbole? How can one single person physically do 1,000 times more work?
It absolutely sounds like hyperbole at first glance. I mean, it sounds ridiculous. But when you look closely at the new workflows, you start to see how it's structurally possible. It is a fundamental shift in how work is generated.
We aren't talking about a human typing 1,000 times faster.
No, definitely not. We are talking about a human directing a vast amount of automated labor.
Right, because Boris himself noted he uninstalled his integrated development environment, his IDE, the core software where developers traditionally type out code. He doesn't edit a single line of code by hand anymore.
None.
None. Zero. Instead, he is landing 20 pull requests, which are basically major finalized code updates merged into the main project every single day just by directing the AI.
To understand how one human can land 20 major code updates a day, we have to talk about agent topologies.
Agent topologies, let's get into that.
We are officially moving past the era of a single AI chat window and into the era of multi-agent swarms. There is this critical concept mentioned in the source called uncorrelated context windows.
What does that mean in plain English?
Instead of giving one single AI a massive tangled history of a problem where it might get confused, you spawn multiple fresh AI agents. They have completely unpolluted context windows. They have fresh brains, essentially.
So they aren't biased by past mistakes.
Exactly. They are thrown at a problem in parallel, acting as a form of what AI researchers call test time compute.
Meaning, instead of the AI doing all its thinking instantly the second you hit enter, you give it time and computational resources to work through a problem step by step, trial and error style.
Exactly. And the real-world results of this approach are staggering. The transcript details how the entire plugin's feature for Claude Code was built over a single weekend by an autonomous swarm of agents managing their own Asana board.
With zero human intervention.
Zero human intervention.
Yeah.
An engineer just gave the swarm a basic spec, told it to use the Asana project management software, and the agents created their own workflow tickets, assigned them, wrote the code, tested it, and executed the entire project.
That is wild.
Imagine being a manager logging into Asana on a Saturday and watching project tickets move from to-do to done by themselves.
It's completely surreal. And the transcript explains that this entire process operates under a master agent they internally call Mama Claude.
Mama Claude.
Mama Claude is a recursive loop that just constantly prompts subagents to go do tasks. If there's a really tough bug in the system, Mama Claude won't just try to guess the answer. It will spawn 3, 5, or 10 subagents to research the code, read the server logs, and test hypotheses in parallel.
It manages the workforce.
Yes. And here's a detail that truly blew my mind. If the AI is looking at the codebase and sees that a human engineer touched a specific file recently, the AI will spontaneously message that human engineer on Slack, ask them a clarifying question, wait for the human to respond, and then get back to work.
The AI is pinging human coworkers for help on Slack.
It is.
It is actively collaborating as a peer, which completely upends the traditional role of a software engineer in a corporate environment.
So what does this all mean? If the actual manual typing of code is essentially a solved problem, if one person is doing the work of 1,000 peak engineers by managing a swarm, how on earth do you even hire for a tech company in this world? What is the job description anymore?
The transcript makes it clear that the hiring revolution is already here. Forward-thinking companies are no longer asking candidates to stand at a whiteboard and invert a binary tree from memory.
Thank goodness that was always a nightmare.
Right. That is totally obsolete. Instead, they are having candidates pair program with tools like Claude Code to solve a complex problem. And then the hiring managers aren't just looking at the final code, they are reading the raw transcripts of how the human interacted with the AI agent.
What are they looking for in the transcripts?
They are looking for a spiderweb graph of totally different higher-level skills.
They want to see, did you know to look at the system logs? Did you use plan mode effectively? Do you genuinely understand complex systems? Can you gracefully correct the AI when it inevitably goes off the rails and starts hallucinating?
Exactly. It is no longer about memorizing syntax. It is entirely about product sense and systems thinking.
And importantly, it requires a massive cultural shift from hubris to humility. In the old tech world, the ultimate status symbol was the senior architect.
The person who knew everything.
Yes, this was someone with decades of hard-won experience, rigid methodologies, and very strong, unshakable opinions on exactly how things must be built. But as Boris points out, those strong opinions are actually a massive liability now.
Why a liability?
Because whatever architecture you firmly believe is best today might be rendered completely obsolete by a new AI model release in 3 months. The new superpower in the tech industry isn't rigid expertise. It's scientific thinking, first principles logic, and the profound humility to constantly admit when you are wrong so you can adapt to the new reality.
It really is the end of the hyper-specialist. The literal job title of software engineer might disappear entirely in the next few years.
What replaces it?
It's going to be replaced by generalist builders. We are already seeing finance professionals, product managers, and graphic designers all shipping production code right now because the AI completely levels the playing field. Everyone is a generalist when the AI handles the specialized syntax.
If we step back for a second. If we really look at this trajectory.
If we connect this to the bigger picture, this exponential acceleration we are talking about isn't just about making cool apps faster or boosting corporate productivity. There is a very serious, very real horizon approaching.
The safety horizon.
At Anthropic, they operate under a strict safety framework, and the next major threshold they're watching for is called ASL4, Anthropic Safety Level 4. This is the threshold where AI models become recursively self-improving.
Mama Claude spawning sub-agents to fix a bug is one thing, but ASL4 is entirely different. That is the AI actively rewriting its own core architecture, making itself fundamentally smarter, faster than human oversight can actually manage or comprehend.
Yes. And with that level of autonomous capability comes incredibly severe existential risks. We are talking about the potential for the model to be misused to design novel bioviruses or to autonomously discover and exploit zero-day cybersecurity vulnerabilities across the global internet.
The stakes are truly existential.
And this is exactly why Boris Cherny chose to work at Anthropic in the first place. The transcript notes he was living in rural Japan, reading Hacker News every morning, just watching this AI wave build from afar. As a massive sci-fi reader, he knew exactly how badly this exponential curve could go if handled recklessly.
So he sought them out for their safety protocols.
He chose Anthropic specifically because of their intense, mission-driven focus on AI safety. It isn't just about building a cool coding product for them. The product is almost secondary. The primary overriding mission is preventing catastrophic misuse as we trace this exponential curve upwards toward ASL4.
It is a massive amount to process. In one deep dive, we've gone from a solo developer who just wanted to test an API by building a text prompt in a retro 1960s-style terminal,
to witnessing multi-agent swarms executing weekend-long software projects on Asana by themselves.
And now we are staring down a near future where the manual chore of coding is practically solved for humanity while facing the existential horizon of self-improving models. The sheer velocity of this change is just breathtaking.
It really is. And this raises an important question for you, the listener. We talked a lot about latent demand today, the idea of making the things you are already jumping through hoops to do easier.
Right.
Look closely at your own daily workflow, no matter what industry you are currently in. What are the tasks where you are currently acting as the scaffolding? What friction are you forcing right now that an AI could simplify tomorrow? Because the tools to automate that friction are likely already here, or they're coming in the next 6 months.
I love that perspective. And I want to leave you with one final, slightly provocative thought to mull over, based on everything we've uncovered. We know from the source material that Mama Claude is already spawning subagents to do tasks in parallel. And we know that Claude is already proactively messaging human engineers on Slack for clarification when it gets stuck on a problem.
It is already happening.
But think about where this naturally goes next.
Yeah.
If every human engineer is soon replaced by a generalist builder who is managing their own massive swarm of AI agents to handle all their communication, coding, and daily tasks,
Yeah.
how long until the AI agent reaching out on Slack for clarification is actually talking to another AI agent responding on behalf of the user? When your swarm starts managing my swarm, and they're autonomously negotiating the code, the architecture, and the project management between themselves in a matter of milliseconds. Wait, in a matter of milliseconds, who is actually the user and who is the tool?
That is a fascinating thought.
Thank you so much for joining us on this deep dive. Keep questioning the scaffolding in your own life.